today's lecture is not going to last long. It's only over 2.4, which is one of my favorite lectures because we had to call out dumb and um, see how this happened. So 2.4, actually, are there any questions about anything before this? It's on Lori. It's only, are we a little early? No? Okay. It's only you, Jacob. Are there any questions from any sections before this? This hasn't been bad, right? Chapter 1 and Chapter 2 are a nice, easy intro into statistics, right? I say easy in that there's not a lot of math. It's just definitions. And it's very straightforward, okay? So do you guys have any questions before I just get kind of, I'm going to show you examples I found. I had a student email me a good example as well for these graphs. It's just kind of fun. Okay, so 2.4 is really about misleading graphs, and they can be very misleading. And it's not, the sad part is I'm not talking about graphs that are lying. Okay, there's graphs that lie. Actually, let me show you a graph that's just lying. Hold on. I'm Googling misleading graphs, and I bet when I do this, I can find a graph that's just flat out lying. Yeah, here we go. How do I share? Hold on, let me share this screen real fast. Share screen, yeah. Okay. See my screen right here. See this bar graph? I don't know why it's doing. Okay. See this bar graph, or I'm sorry, this pie chart? This pie chart is just lying, right? We learned that a pie chart, each slice gets the percentage it's supposed to have. I mean, this has 65, 67. I mean, this is dumb. This is more dumb. Not trying to be like sneaky. It doesn't take hard at all for our brains to go, whoa, those don't add up to 100. And they're not the same. And this is definitely cut into thirds. Okay, that would be not, to me, that's not misleading. That's lying. Okay, misleading. And then I'll show you. Let me switch out of. Let me switch screens here. And this is the picture a student sent me. I had to like save it and do the screenshot. Now, this would be a misleading. Now, look, I'm going to do this for both candidates because I don't care about the politics, okay? That's not what I care about. I'm definitely not in the mood to start a political conversation in this class. But I want to show you how it'll pop up on both sides, okay? So this was an example. Let me share this screen. Right here, yeah. Okay, here's a good misleading example. Now, at least this company or this the Lincoln Project, at least they put the lines here for 30 and 40% to let you know, hey, it's not starting at 0, but you're really supposed to start graphs at 0. Okay, you really are. If not, you're misleading. It looks like, so what is this about? Biden leads Trump among active military duty. Okay, so Biden, they did a poll, I guess, and they found out, I'm not sure who did it. I don't know anything about this. Again, we're not going into politics. But they did a poll and they found out that active duty military, 43% are supporting Biden, where 37.4% are supporting Trump. But if you look at this graph, it looks like Biden has a much more commanding lead than just, less than 6%. Actually, less than 6%. Okay, so less than 6% lead. It looks like a huge gap going on, right? That's kind of what this is saying is, let me see if I can find another one. Actually, I think this one did it too. Yeah, this is a Trump one. I said I would do both of them, right? Here's a Trump one. Yeah, I like this. This is from his last election, I guess. And I have no idea the context, guys. I don't know what this was about. Apparently it was about Colorado and maybe who supported Trump in Colorado. I have no idea. So don't ask me about it. But I want to show you how it's misleading. It looks like he's killing it in Colorado, right? But really, he's only 2 percentage points up. And a lot of times if you read polls, we can go into that more probably later, but if you read polls, there's always a degree of error. I should say a good poll is going to have a degree of error. And it's because they are not reaching the entire population. This whoever it is that's polling, 538, some other good polling, Pew, let's say Pew, who's probably the most reputable. When they poll people, they can't get every Colorado voter, right? I mean, that's just not possible. So what they do is they'll say, they'll say something like Trump's up on Clinton but there's a degree of freedom by about 3%. So look, if it was a 3% error, we can't say that Trump is up on Clinton, right? It could be the complete opposite, okay? Because of that like really it might be that it's 42%, right, Trump, and 46% Clinton, because we're saying there's this 3% degree of error. So just be careful what you see in the news. And not that the news is, I don't want to say that the news is wrong. It's just they'll pop these graphs on there that can be so misleading, and it bothers me as a math person. And both sides do it. It's not like I'm not trying to condemn one side. Both sides do this. And if there's a story they're trying, either side is trying to kind of shape, they'll do this kind of stuff. And if you look at your book on page 81, it goes over that exact thing. It talks about like passenger traffic at Denver International Airport. So the top of page 81, same thing. And it just talks about the millions of passengers. If you look at it, if it started at 0, it doesn't look any different. But if you started at like 50, you see this huge difference in the change, or it looks like a huge difference in the change. But the problem with that is our brains think of things as ratios, right? Let me give a good example. Yeah, this is a good one. This is just one that's on, I found on Google. Okay, guys, I'm gonna share my screen again. So our brains like to think of graphs and bars as ratios. So when we see this, if we didn't look at the side, if we see this, it would look at whatever we're talking about here, that 1998 was about half of 1999, right? And it's because that's the way our brains think. We don't automatically think of the left-hand unit, okay, or the left-hand number. So, of course, if we look at the left, that's not true at all. And actually, this is kind of how it's written if it started at 0. There's not that much of a difference. The same thing would have happened with that Trump and Clinton graph, right? If that started at 0, it's not going to look like that because the units are going to be consistent on the graph, okay? So I'm going to stop sharing that, come back to me. I'm going to kind of go through this, though, and see if there's any real, oh yeah, the area principle. So we often use images to compare objects. Larger images correspond to greater amounts. To use images properly in this way, we must follow a rule known as the area rule. And when amounts are compared by constructing an image for each amount, the areas of the image must be proportional to the amount. That's what I'm talking about, okay? So since we're using this bar graph, if it's just a little, if that green to orange or green and orange bars, it looked like the orange bars were half the amount, half the area, right? But they are half the area on that left-hand graph, but they're not, in reality, they're not half the amount of whatever they were measuring. So for example, if one amount is twice as much as another, its image should have twice as much area as the other image. When the area principle is violated, the images give a misleading impression of the data. And again, this is where you're not lying. That company isn't lying, right? I mean, the Trump campaign here in Colorado is not lying. 45% and 43% are the numbers that came from this poll, right? But by putting them on a graph that way, it's misleading, okay? It's very misleading. Sometimes you don't want to mislead. I mean, like, I feel like, and I guess it's how you view politics. And you'll see this a lot where, like, it'll look like someone's so much further ahead, but in my brain, I'm like, man, you don't want to, like, people might not show up to vote, because in reality, the race is a lot tighter, right? So if like, hey, my guy's up by, you know, only 1 or 2%, but this graph makes it look like he's up by, you know, twice the amount, like, I might not go, I'm going to go vote, but I might not go vote, or somebody might go vote because I know the guy's going to win anyway. I don't have to worry about it, right? Where that's just my opinion. That's more of a psychological thing, not a stat thing, okay? 3-dimensional graphs. Yeah, beware of 3-dimensional bar graphs. If you can see the tops of the bars, they may look shorter than they really are. That happens, and it happens right there in that graph. So there's nothing wrong. This is on page 83. There's nothing wrong with that little graph that they're showing, but it just kind of looks smaller whenever we can see the top for some reason. So even though that graph is about a third, a little less than a third, it can kind of mislead and look like it's not. It's actually taller than it really is. Did you guys see? I assume if you haven't emailed me, you did not see any graphs. Let me go through some of these and see if I can find some good ones, just So we have more than a 10-minute lecture today. And I just don't want to go on to chapter 3 yet. Chapter 3, the numerical summaries. Hold on. See if we find any good ones. Oh yeah, this is a good one. And I'll tell you, this is one I'm working on this doctorate, and it has we do a lot with this stuff. Share screen. I'm gonna go to this one again. So and I know it's a sad graph to mention in a college algebra or in a class at college, but the diminishing financial return of higher education. So the cost of the four-year degree versus the earnings of a four-year degree. So we've got the years down here, and we've got the cost on the left. Now, it's adjusted to $2010, which is great. So here's the earnings, and here's the tuition. Now, there's a few things wrong with this. First off, at some point, it just stops, right? I mean, you keep earning money throughout your life, but college stops, okay? So that's a major issue with this graph, in my opinion. But if you look at it, it looks like it's kind of consistent here, but it looks like it's like 5 times the amount. Do you guys see that? But really, it's 45,000 to 95,000. It's just double, right? But this line graph makes it look like it's 4 times the amount up. And the other issue, though, is, of course, after 5 years, it stops. And then, you know, it's not the cost of college, unless you take out a ridiculous amount of loans, eventually it ends. And then your earning kind of takes over on the long run. And I'll tell you, and it's not because I work at a university. If it actually had a negative return, I promise you I would not teach at a university. I think that would be wrong. It would feel like I'm working at a pyramid scheme, okay? But it does. Every indication that every study that's been done has shown that in the end there is a positive correlation with, and we're going to talk about that actually, correlations, not this aspect, but there's a positive correlation with a degree. Okay. Hold on. Didn't mean to go on that rant. Oh yeah, these are always the worst. Okay, these I think are my least favorite. I don't know if it'll go to it. I'll probably go to something weird. Why can't I see the picture? Hold on. Is it gonna let me? Nah. Yeah, I know that's fuzzy. These are my least favorite graphs, and they pop up a lot. And it's when a company or whoever doesn't use bars or doesn't use lines. They'll do like people, or they'll do buildings, or there's one that it was looking at different types of like video game consoles, and it used like the picture of each console, but the consoles at the time looked different. It's not like today where they don't look that different. But it didn't make any sense, and it made it where it just really extremely misleading. It should have been the way it was worded, not just a little misleading. Okay. Hold on, let me zoom that down to normal size. Get rid of it. Stop sharing. Okay. Okay. You're back to me, right? Yeah, good. Okay, guys, I mean, that's it. I want you to look at number, I guess there's questions throughout this section. Yeah. Okay, so the homework is kind of weird because it starts on page 83 in the homework. But I just want you to do 1 through 14 is fine. 1 through 14 on page. It starts on page 83 and then it goes to 85. So 1 through 14. Not a long lecture.